My research expertise is the mechanics of bone and adaptation of bone. The primary application of this work is understanding osteoporosis-related fractures. My work right now is concentrating on spinal fractures. Spinal fractures are the most common type of osteoporosis-related fracture. And we don't really know how they happen. About half of them can be associated with a fall or other kind of large load. The other half occur for an unknown reason, and we're not sure how. So what we're looking for are ways of detecting who would be at risk for one of these spinal fractures. You can take a bone scan, and the bone scan, or DEXA, it's called dual energy X-ray absorptiometry, can tell you a little bit about who's at risk, but there are other aspects of the bone that are also important. In my laboratory, my research concentrates on the bone remodeling process, which is the process through which damage is repaired in your bone. So this is a blown up piece of trabecular bone from the spine. And what the bone remodeling process does is when there's little tiny cracks or other damage, cells come in, remove the damaged tissue, and then other cells come in and replace it. What we think right now is that those holes, the divots caused when the cells remove the tissue, are actually acting as stress concentrations and impairing the mechanical performance of the cancellous bone overall. In other words, we're sort of saying that the repair process is part of the problem in this case. And the way I like to think about it is, imagine road repair crews. If you had cracks in the road, while the repair crew is repairing that road, you can't drive on the road, so it's not very useful to you. Well, the same sort of thing is happening here. If you have too many of these repair crews, too many of these holes, there's a lot less material, or there's less material to hold up the bone structure. And so in my laboratory we use imaging techniques and materials testing to understand how to see these cavities and to see if they lead to more damage in the trabecular bone or modify its performance as a whole.